These notes are about the intro to the periodic table. Your learning target is, I can determine information on elements based on their location on the periodic table. First, we'll start off with an elemental review from last unit. Remember that all matter is made up of atoms. Specific combinations of protons, neutrons, and electrons make up specific atoms called elements. Each element has its own set of characteristic properties. What are chemical symbols? Each symbol has one or two letters. The first letter is always uppercase. And if it has two letters, the second letter is always lowercase. Some examples that we have. Carbon. Carbon symbol is one uppercase C. Copper. Copper has an uppercase C and a lowercase u. Chlorine is Cl, so uppercase C, lowercase l. And cobalt. Cobalt is an uppercase C and a lowercase l. So notice that the first letter is always uppercase, and if it has a second letter, it's always lowercase. This is extremely important. So these are all elements. And how do we know that? We know that because they all only have one capital letter. If we take a look at this last one, carbon monoxide is a capital C and a capital O. So this is what we call a compound because it has two capital letters. And you can see it's very important because cobalt with a capital C and a lowercase o is a pretty blue crystal, while carbon monoxide, capital C and capital O, is a poisonous gas. So very important to know whether a letter is supposed to be uppercase or lowercase. What is the history of the periodic table? It has been developed over many years. It organizes the 118 elements in ways that are useful. It organizes the elements by increasing atomic number. So remember, that's the number at the top of each symbol. So 1, 2, 3, and so on. And the elements are placed near other elements with similar properties. We have three classes of elements, which we'll take a closer look at. So one class is, what are metals? Metals are located centrally and on the left. So all of these elements colored in red is where our metals are located. You can see that the majority of the table are metals. So what do we know about metals? Metals have a high electrical conductivity. Metals conduct heat. Metals are malleable and ductile. And these two words are fancy words for saying flexible and bendable. Metals also have luster, which means that they are shiny. Our next class is the nonmetals. So what are nonmetals? Nonmetals are located on the right, and hydrogen. So as you can see, most of them are located on the right side, but you have the one exception over here, that is hydrogen. Nonmetals are poor electrical conductors. They are brittle, and they are non-lustrous, which means that they are not shiny. And our third class is the metalloids. Metalloids are located in between the metals and nonmetals, so they're the ones in orange there. Metalloids share properties of metals and nonmetals. How are ions represented on the periodic table? If you remember back to last unit, ions are atoms with different numbers of electrons. Ions are charged atoms, if we remember our plus and our minus. So the periodic table actually breaks it down with it as well. So in column 1, our very first column here, all these elements have a charge of +1 when they become an ion. all of our elements in column 2 become a +2 charge when they become an ion. If we skip over to the other side, boron would be a +3. Every element in that column would have a +3 charge when it becomes an ion. The carbon one would be plus or minus 4. Nitrogen -3, oxygen -2, fluorine -1. So depending on which column it's in, we can identify what ion charge it would have just by its location on the periodic table. Let's do some practices. So if we found an unknown substance that was shiny and malleable, would it be a metal, a nonmetal, or a metalloid? So think back to your properties. Which one is shiny? Metal. Which one is malleable? Metals. So since they are both properties of metals, that would be a metal. Let's take a look at another example. If it's brittle and doesn't conduct, so which one, metal, nonmetal, or metalloid, do those properties follow? Well, brittle was a nonmetal, and doesn't conduct was also nonmetal. So this substance must be non-metal. Let's take a look at the last one. It's shiny and doesn't conduct. So shiny, as we mentioned before, well, that must be a metal. But doesn't conduct, as we looked before, that's a nonmetal. So if it has properties of both metal and nonmetal, that would mean that it is a metalloid.